Right, let's see how to do this question. We have been asked to prove that triangle AOD is congruent to triangle BOC. And we have been told O is a center. The moment you got to know O is a center, you got to realize that OA, OB, OC, and OD, all of them are radii of the same circle. So OC is equal to OD. Why? They are radii of the same circle, equal to OB, OA. Altogether, there are 4 radiuses, but we don't. The plural tense of radius is not radiuses. We say radii. So 4 radii. All right. So now we have been asked to prove AOD. This AOD is the triangle with the tick here, and triangle BOC is the one with the cross here. How are we going to prove these two triangles are congruent? Can we use SSS? We have 2 pairs of equal sides. We have AO equals OB, we have OA is equal to OB and OD is equal to OC, but nothing is said about AD and BC. They are silent about it. So triple S is not going to work. What about SAS? Would that work? We need 2 pairs of equal sides and an equal angle, but that equal angle has to be the sandwiched angle, the included angle. Can we use that? All right, I see this. See, there are 2 lines intersecting at O. So when lines intersect, the vertically opposite angles that get formed are equal. What does that mean? If this is Y, this has to be Y. Why is it? When lines intersect, the vertically opposite angles formed are equal. So now we are in a position to use SAS. Just a matter of recording what we were speaking all this time. So let's say in triangle AOD and triangle BOC. All right. So what's the first thing we found? We figured out that AO has to be equal to, let's start from the center end, right? OA is equal to OB. Why is it? Those are 2 radii of the same circle. So OA and OB are radii of the same circle. Then we have OD is equal to OC, the same reason. OD and OC are radii of the same circle. Then, but let's get in order. Since we are going to use SAS, after using an S, now let's go for A. Let's go in the order, then it's easy for us to keep a track. So we are done with the S. We're done with the S. Now let's go for the A. What's the A? That is angle OAD. Angle OAD is equal to angle, oh my bad, not angle OAD, it's the angle AOD. And where I have marked as Y. Angle AOD is equal to angle BOC, vertically opposite angles. Right, we're done with the A, SA. What's the next thing? We need another pair of S. That is OD is equal to OC. What's the reason? OD and OC are radii of the same circle. So therefore, triangle AOD is congruent to triangle BOC. And what is the condition? SAS. All right, this is the part A of the question. Let's see what the part B is. Making the part B to the screen. Right, here comes the part B. Asking what is the relationship between the length of AD and length of BC. All right, let's see what the relationship is. So just a while ago, we proved that the triangle with the tick, let me color in black, this black color triangle, that is congruent to this green triangle, to this green one, let me color in green, this triangle. So where is AD? What is AD? AD is a side of this black triangle. And what about BC? BC is the side of this green triangle. So what can you say about AD and BC? They are two sides. They are two sides of what triangles? Congruent triangles. But the main question that you have to ask yourself is, are they corresponding sides? How do you figure out whether AD and BC are corresponding sides? Look for the AD's location. Where is AD in the black triangle? In the black triangle, AD is front of the angle which we have marked as Y. And in the green triangle, where is BC? It is also in front of Y that we marked in that triangle. What can you say about AD and BC? They are corresponding sides. Why? They are in the same location. So AD and BC are corresponding sides of congruent triangles. Therefore, AD equals BC. Why? What's the rule? The rule is, if two triangles are congruent, their corresponding elements are equal. So since the triangle AOD is congruent to triangle BOC, their corresponding elements should be equal. So AD and BC are one of the corresponding elements. What are those? Those are corresponding sides. So due to that fact, AD is equal to BC. All right, let's look at what the part C of this question is. We have been asked to prove that triangle ADC is congruent to triangle BDC. All right, how do we do this? First of all, we got to know where ADC is. So where is ADC? Now, students, in part B, we proved AD is equal to BC. So I put 2 bar. Right. So prove that triangle ADC. Where is ADC? That is this triangle. Let me draw the outline. Let me draw the perimeter of that triangle in orange. So you are supposed to prove this orange triangle, it's congruent to triangle BDC. So let me draw the perimeter of BDC in blue. All right, students, what's the strategy? First, let's check whether we can use SSS. Are we in a position to use SSS? Let's see. We know AD is equal to BC. This AD is equal to BC. That's one now for the SS. Then we know that CD of the orange triangle is equal to CD of the blue triangle. It's a common side. CD is shared by both. So CD is equal to CD. We have a second S. We are in need of another S. What is the remaining S we have in the orange triangle? That's AC. And what is the remaining side we have in the blue triangle, that is BD. Any way to say that AC is equal to BD with reasons? Yes, we can, right? How? What about AC? What is AC? AC is a diameter. And what about BD? BD is also a diameter. Why? Both AC and BD are chords that's going through the center in the circle. So AC and BD are diameters of the same circle. So obviously they'll be equal in length. So which means we have three pairs of equal sides, which leads or which takes us to use, or which will take us to which we can use to prove that the two triangles are congruent under SSS. Let's record what we spoke all this time. So in triangle ACD, I'll use the same in triangle ADC and triangle BDC. So ADC is the orange triangle and BDC is the blue one. Right, let's start with the first S, that is, we know AD is equal to BC. AD is equal to BC. How do we know that AD is equal to BC? Did they say? No, they didn't give us. That's what we found out. Why? In part B, we said why AD is equal to BC. They are corresponding sides of congruent triangles. Congruent triangles what? What are the two congruent triangles? Since there are multiple triangles we are dealing with, let's say the corresponding sides of congruent triangles. What? Congruent triangles AOC and BOC. It's not AOC rather. Congruent corresponding sides of congruent triangles AOD. We are looking at the smaller one. AOD and BOC. Right. And then comes the next S, that is CD of triangle ADC is equal to CD of triangle BDC. It's one line segment acting as a side for both the triangles. What do we call that as? We call such sides as common side. CD is the side of both the triangles. CD is the side of the orange triangle and it's also a side of the blue triangle. Then we have AC equals BD. That is why? Those are diameters of the same circle. Those are diameters of the same circle. Right. So therefore, triangle ADC is congruent to triangle BDC. What is the condition? SSS. Now, some of you might think, or might have used SAS, right? Now, why it says, some of you would say, this angle here is 90. In the orange triangle, there's a 90. And in the blue triangle too, there's a 90 here. So due to that fact, we can use SAS. Yes, you can use SAS, but The reasoning matters. Why do you say this angle here is 90? Does it because it looks like 90? Is it because it looks like a L shape and it should be definitely 90? If that is your reasoning, that's wrong. You guys are still in grade 10 first term, but later on in our O-level syllabus, we'll be learning this has to be 90. Not because it looks like 90. It is because there's a rule which says angles subtended by the diameter and the circumference is 90, or angles of a semicircle is 90. But you guys are still in grade 10 first term. You haven't used that rule, you haven't learned that rule yet. So if this type of question comes in your first term exams, can you take ADC as 90, though it is 90? No, because you haven't learned the rule yet. So when you're in grade 10 first term, the only option you have for these two, the only option you have to prove that these two triangles are congruent is S, S, S. A very important learning point is not only in this question, any geometry question that you get in papers, just because an angle looks like 90, let's say there's an angle like this. What's this black angle's magnitude? Just because it looks like 90, you cannot say 90. Remember, in the paper, what they give you are sketches, not real diagrams. Those are just rough sketches. So without a valid reason, without backing, if you cannot back your answer with a reason, if you are just saying because it looks like 90, I'm taking as 90, then you're wrong. Right? You should be having a proper reason to say why it is 90. Your reason can't be it looks like 90 or it is L-shaped, so it's 90. That's a wrong reason. Hope you understood.